Hey everyone, welcome back to another video by Camroom 5. In today's video, we're going to start talking about the concepts of states of matter, and we'll see how the particle theory of states of matter is applicable to solids, liquids, and gases. So let's begin. First, we need to talk about what are the basic features of matter. So first is that they have mass. So anything that has mass is obviously matter. Then we have the concept of occupying volume. So matter occupies volume. The third thing is they are made up of particles which could have atoms on them, they could be molecules, or they could be ions, or they could be a combination of atoms, molecules, and or ions. Then the idea is that they are constantly in state of motion, which means based on their temperature, they show motion. You can see the picture of the particular arrangement of solids, liquids, and gases. So let's see. When we talk about matter, we need to understand their concept of arrangement. When we talk about arrangement, for solids, we use the word of lattice, which means a regular patterned arrangement. So they have the particles repeated in a constant manner. Then when we talk about the concept of liquids and gases, they have random arrangement, which is obviously not regular. When we talk about motion exhibited by these particles, okay, first we need to also write about that particles touch each other in solid state. So particles are constantly touching each other. When we talk about liquids, some particles keep touching each other, and in gases, no particles are touching at all. When we apply the concept of motion, so in solids, we use the word vibratory motion or vibrational motion, which means they vibrate at fixed position in a to and fro manner. Based on temperature, their vibrations can become more vigorous, but they will not move away from their vibratory motion. In liquids, we say they move, and they're moving in a way that they are sliding over each other. So particles are like in layers and clusters, and these particles slide over each other. And then when we talk about gases, in gases, there's the word called translatory motion, which means they are moving very fastly in straight lines in random directions. So random directions. So they are moving in random directions for gases. Let's have a quick look at the concepts of changes of states of matter. So we have solids, liquids, and gases on this screen. When there's a conversion from solid to liquid, there's obviously called melting. And then when liquid converts into gases, we call it boiling. Another phrase we have is called vaporization. Evaporation is a little different, but at the end of the day, it is liquid to gas. So vaporization is the most academically correct word, which is applied to all cases. Solid to gas is called sublimation, we know this. Liquids becoming solid is called freezing. And then gases becoming liquid is called condensation. If there's a gas turning directly into solid, we call it deposition, which is the reverse of sublimation. We need to understand that when we talk about solids, liquids, and gases, and there are changes of states happening, the examiner can ask us how the changes are represented by their motion and their arrangement. So we need to remember that we can say that in solids, particles were vibrating, they were in a lattice, they were in a regular arrangement, they were touching, all the particles were touching each other. But now if you're turning it into liquid, there's obviously changes in arrangement and motion. So you can say they were not moving from their positions, but now they're moving from their positions. And now they're sliding also over each other. First, they were in a proper regular pattern. Now they're not in a regular pattern. First, all the particles were touching each other. Now, only some particles are touching each other. Now, if it changes into gas, you can see on the right side of the screen, you can say now the particles are doing translatory motion in random directions. And now, first, like when they were liquid, the particles were, in solid they were not regular, but in liquid you can say they were not regular, and in gases they are still not regular. So these are how, this is how you explain these kind of changes based on touching and arrangement and all. From solid to liquid, particles have to absorb heat energy so that they can overcome their attractive forces and break free from them. From liquid to gas, there's the same idea that particles absorb heat energy. Once they absorb heat energy, they overcome the attractive forces between them. But when a gas is becoming liquid, when a particles want to come close, like gas to liquid, they release heat energy. So whenever particles are coming closer, for example during condensation or for example during deposition, particles release heat energy. So this is how we explain the ideas. Now it's a good time to understand this release and absorption of heat energy based on heating and cooling curve. Imagine I'm heating a substance and I'm plotting the heat energy given on the x-axis. For example, 40 joules or 80 joules or like 120, 160, and after every 40 units I'm making it on the x-axis. So on the x-axis I'm plotting how much heat is given to a beaker of ice. And on the y-axis I'm placing the temperature, right? I'm placing the temperature. I'm starting my y-axis from minus 20 degree, and after every 20 degree increase I am plotting the value on the y-axis. When I started giving heat to this ice block, obviously heat was absorbed by this system. And when heat was absorbed by this system, the starting temperature was minus 20. But as heat was given, the temperature started to increase. After a while, the temperature stayed constant for a while, and then it started increasing again. So there's an increase, there's a constant, and then it starts to increase again. It keeps on increasing until it reaches 100, and then it starts becoming constant again. So at 100, it starts becoming constant again, and after a while, it starts to increase again. We need to understand why is this happening. So in the beginning, when the temperature was minus 20 degree for the ice, it wouldn't start to melt right away. First, the particles will absorb heat energy. And when they absorb this heat energy, they increase their kinetic energy. Particles absorb heat energy, they convert it into kinetic energy, they move faster, and since they are solids, they will vibrate faster. You can't say they all of a sudden start moving. They vibrate faster. But specifically at a very given value of melting point, what happens is that now the particles are not only absorbing heat energy for the sake of kinetic. The particles absorb heat energy to overcome the attractive forces. The vibrations are so vigorous now that particles overcome the attraction between each other. When they absorb heat, they overcome the attraction, they move away from each other. And that is exactly when the process of melting occurs. So when melting is going on, you can't expect temperature to change. The temperature will stay constant until all the ice has molten. So when the ice has melted, you can expect that the temperature is still the same. So you can see all the heat energy was given for melting so that ice can absorb heat energy, the particles can absorb heat energy and overcome attraction. Now they are obviously liquid. All the ice has properly melted, it's liquid, and now still if you give heat energy, this liquid will absorb heat energy, this water will absorb heat energy. And what is it going to do now? From solid to liquid, conversion has happened. Now it's properly liquid. After it has become proper liquid, again the same thing will happen, that particles will absorb heat energy. When they absorb this heat energy, they increase their kinetic energy and obviously move faster. Now you don't have to use the word vibration anymore. You can call it move faster because now they are liquid, right? And after a while, at 100 degree, so at 100 degree, which is the boiling point of water, change of state happens. So at this straight horizontal line, you can expect boiling to happen, vaporization to happen. So particles now absorb heat energy. They absorb heat energy and overcome attractions between each other. Heat energy can either increase your kinetic or it can help you overcome the attraction. Both things are preferably not happening together. So please rephrase your answers and make them more clear. You will hear in this part, you will say overcome attraction between each other, move away, and boiling or vaporization happens. And after the end of the straight horizontal line, it becomes a gas, and now the gas is, absorbing heat energy. So this is how things happen. Let's revise this idea. So first is then heat energy is absorbed, particles increase kinetic energy, vibrate faster, so temperature is increased. But when melting happens, the energy is used to overcome attraction at constant temperature and they just move away. Then the liquid absorbs heat energy and keeps becoming warmer and warmer by increased kinetic energy. Then during vaporization, particles again absorb and overcome attraction so they can become gas. And once gas is there, it keeps warming up and it increases the temperature. I hope these ideas are clear to you guys. Stay tuned.